We're back with our AP Stats class. Going to go over the next 10 on the multiple choice. We're starting with number 11. Now, number 11 I found really interesting because it's going to ask you to determine if certain data values are outliers or not. But what's really interesting is they actually told you how to do it. All right, I was not expecting this when I read this question. All right, this tells you how to find your fences, right? 1.5 times the IQR, greater than the upper quartile or less than the lower quartile. So they're literally telling you how to do it if you forgot. So that's kind of nice. All right, so let's find the IQR, all right, for our 40 to 50-year-olds. Okay, so how do you find IQR, the interquartile range?
Quartile 1.
All the way, quartile 3 minus quartile 1. So that's going to be 76 minus 70. So what's our IQR? 6. We take that IQR and we multiply it times 1.5. So what's 6 times 1.5?
9.
It is 9. Very good. Half of 6 is 3. 6 plus 3 is 9. All right, now to find your fences, remember we've done this a lot of times, so just a long time ago. The lower fence, it's not left field and right field. Oh, I did say, sorry, get into the T-ball mode. All right, so lower fence is going to be quartile 1 minus your 1.5 times the IQR. So that's 70 minus 9. So what's my lower fence? 61. Nice subtraction. Okay, and then the upper fence is going to be 76 plus 9. So what's our upper fence? 85. Okay, so here are the three values, 60, 62, and 84. So first evaluate 60. Is 60 below the lower fence or above the upper fence? It's below the lower fence. So what does that tell us about 60? No, we can take that away because we're doing it. It's an outlier. So 60 is outlier. Okay, let's do the next one. 62. Is 62 below 61 or is it above 85? Neither. So is it an outlier? No, it's close, but it's not. Okay, let's do 84. Is 84 below 61 or above 85? No, close again, but not. So the only one that's an outlier is 60. So only 60 is an outlier. All right, so that's a question on how to find outliers. And again, I thought this was really nice of the AP exam to actually give you the process of how to do it. Don't expect that on your test. Questions on 11. Let's go to 12. All right, number 12. All right, when I read number 12, all right, it's saying, wait for it. Still waiting. There we go. When I read number 12, it's a good start. It says that the college administrator is surveying a sample of students from the college, from each major offered. So let's think, what are some majors in college? Psychology. Business.
Architecture.
We just said that, architecture.
Engineering.
Right, see where we're going? See all the different majors? It's saying we're doing 5% of students within that major from each one. So some from engineering, some from architecture, some from psychology, some from business. Do you remember what it's called when you do a little bit from each? No. It's stratified. All right. Think of the buffet, right? Think of the buffet. I just went to one on Easter. A little bit from each one. All right. Well, this one we went to super nice. Went to Hotel Galvez for brunch. It was super nice. A little bit of each. And so as I was doing it, what was I thinking?
Stratification.
Stratified. Here's my stratified sample. That's right. That's what it is. Stratification is right. It is. Let's do 13. All right. 13 gives us the graph of the population distribution of this random variable x, which gives us a mean and a standard deviation. It says which of the following would be a sampling distribution model of this sample mean for sample sizes of 40 taken from this population. This was a question ripped from chapter 18. We've done a question exactly like this in chapter 18. I know that was many, many months ago, but here's what you do. Your sampling distribution model right? So this is the new model. All right, the mean is the same. So what is our mean? The mean is the same. 85. Do you remember how to find the new standard deviation? It's okay if you don't. The new standard deviation is your population standard deviation, that's sigma, divided by the square root of the sample size. Okay, this formula is on your formula sheet. Okay, so let's find that. So our standard deviation was 18. And what is our sample sizes? Sample size of 40, right? Sample sizes 40. Okay, so let's find our new standard deviation. Go to your calculator. So open up your TI-84. 18 divided by the square root of 40. So we have 18 divided by second x squared, which is the square root of 40. 2.846. So write that down for your new standard deviation. 2.846. All right, so what I did was I made my own little curve, right? Right down the middle is still 85. But now when I move 3 up and 3 down, what am I using as my new standard deviation? 2.8. Excellent. So I thought, okay, this is going to be, close to 88, getting close to 91 and about 94. Again, I'm just rounding here, guys, right? Are those numbers exact? No, but I'm giving myself a ballpark of what I can expect. So about 82, about 79, about 76. So when I go to my answer choices, I'm looking for my curve, right? I'm looking for my curve to have no values lower than 76-ish and no values higher than 94. So look at your answer choices. Do you see which one kind of matches what we just made? Do you see which one it is? Yes, Diego, which one is it? It's B, right? Because we have our lowest value around 76, the highest closer to 94. You guys see that? That's 13. Questions on 13. Again, I don't think this question is difficult if you knew to do this. All right, but how many of you knew to do that? Nobody. All right, then. Confidence. Maybe you'll know. Next time. It's always good to know that school comes last. All right, number 14. Number 14. Really good question. Super challenging question. I would imagine if you get this right, you're getting a 4 or 5 in the exam. All right? Amazing question. So it says, we have a confidence interval. Do you guys see that? All right, so I wrote down my original interval, all right, is just a little delayed, 0.14 to 0.2. Oh, okay. Now, do you guys remember what the middle of the interval is? Do you remember what the middle of the interval is? No.
Like the name of it?
No, I mean, you can give me, there's lots of answers here. What's the middle of this interval? Because it's like what we started with the interval. We start. You're fine, sure. What was it number-wise? It's 0.17. Do you remember what it is? No? There's a couple things. It's sad. It's the statistic, all right? So in this case, we're talking about proportions. So what do we say is our sample proportion? You remember the symbol?
Oh, SE?
A hat with what letter? Proportion. P hat. So our P hat here is 0.17, right? So this would be plus or minus the margin of error, right? And what's the margin of error? How do I get to 20? How do I get to 14 from 17? 3%, right? So our margin of error here is 0.03. Everybody okay so far? No, we're not okay. No? No. So right in the middle is your statistic. In this case, we're talking about proportions. So I did a p hat is 0.17. So to create the interval, you do your sample statistics. So we think it's 17%, plus or minus a percentage. In this case, 3%, because we go 17 plus 3 is 20, 17 minus 3 is 14. So that's called a confidence interval. We think it's 17 with a little wiggle room on either side. Everybody good? Okay, now they're telling us they made a mistake. They made a mistake, right? Unfortunately, they used the wrong proportion. So you see how we use 17? Yes? Now the real one is actually 0.27. All right, so really, this is the new one. Right? I mean, they made a huge mistake. All right, so it's p hat plus or minus z star times the standard error of p hat. All right, this is our new one. All right, now we have to use 0.27. Okay? Now, here's the thing in the problem that's going to help you answer this question. It says in the problem that they're using the same confidence level. Be nice to yourself. Does it tell you what confidence level? No. So what one am I going to use when I make one up? What? 95%. Because I know that Z star. I have it memorized. What's the Z star for 95% confidence? 1.96. If you want to use that one, then make sure you use 90%. Okay? Everybody okay so far?
Yeah.
Times. All right. Now, who remembers the formula for the standard error for p hat?
Standard error over something over n.
It is something over n. That's right.
The hat Q hat.
Nice. What up? And if you forget, where is this? Formula sheet. This one is there.
Did you write it?
Yeah, it's
Okay.
a little delay.
Yes, we've already established that, right? All right. So I have 0.27.
No, it's only one.
Okay. All right. So this is 0.27. All right. And then what's my Q hat then?
373.
7.3 is right. Now, does it tell us a sample size? Does it tell us a sample size? No, but it says in the problem, right? It says the problem. What does it say? No, but we're same confidence level. So I'm going to do the same sample size. So what sample size do you want to use? Doesn't matter. Do you know which one I use? Definitely not one, right? I got a sample of one. I did 100. Well done, but we're thinking the same. All right. Is everybody good on the new interval? Everyone see the new interval?
Yes.
Yes? Okay. All right. We're good. All right. You ready to calculate that? All right. Let's calculate it. And really, all I care about calculating is after the plus or minus. Because do you know what's after the plus or minus? The margin of error. I already know the margin of error for the first interval. What was the margin of error for the original interval? 3%. So let's see what our new one is.
It's going to be 12. No.
We may get lucky here, but I feel like I need to do a little bit more work. We'll see. All right, so we have 1.96
There's no guessing.
times. Actually, you know what? Let's just do this. No, let's try it. Let's see if I get lucky. If not, I'll figure out right. Times the square root of, was it 0.27?
Wait for.
Yeah.
It's really helpful to like try plugging this in, Adrian.
You got a haircut?
What is up?
I finished my test. Wait, you could.
I mean, sure. I'm kind of in the middle of something.
I got a pass from my teacher.
Very good for you. Let me do this. Let's see what I put it together. You guys can see. Well, wait for it. I'm going to show you why. So the original p hat was what? What was the original p hat? 0.17. So watch what I do here. Let's see if Adrian's good with this. So this is going to be 0.83. Yes? You good, Adrian? Right? Same thing. Okay, divide by 100. All right. All right, compare these. These are the margins of error I want you to compare now. Okay? Our new margin of error is 0.09, so about 9%. And this is the original. I know it's not 3, so I'm using a different confidence level. They probably used, let's see if they have a lower margin of error. So that's going to be a smaller interval. So that means they're going to use, this would be smaller. All right, so probably maybe 90%. Okay. Anyway, the point is, this is the original that I made up. Okay. So how would you compare these margins of error? This one's higher. So if the margin of error is bigger, what happens to the interval?
It gets bigger.
It gets, let's use the right word, it gets wider. Nice. So look at your answer choices. Okay, wait for it. All right, that has to say that the interval is wider. So I'm going to cross out A and B and E, right? So now I'm between C and D. All right, let's see which one makes sense. Looks like D because it says the correct sample proportion is closer to 0.5, right? And 0.27 is closer to 0.5 than 0.17 is. So 14 is D. Uh-oh. Come on, you can do it. Oh, no. Oh, no. It's probably because I'm trying to use the TI-84 thing. Let's try this. D. Yes. All right, give me one moment. All right, let's go to 15. All right, so this is a great question for us because when you read it, you're going to choose what test to run. All right, and Eder, you had a question similar to this. Yesterday we were talking. This might help you with that question you had, okay? All right, it's not a t-test. It says percent. The moment I see percent, all right, I'm going to be thinking proportions. Proportions, we use the normal model. All right, so the question is this a one proportion or a two proportion z-test? Well, let's try to think of our hypotheses. That's what I like to do when I have to run a test. But first of all, let me ask, do you guys know why I know to run a test? Do you know what in the problem tells me, hey, you should run a test with your technology? Demetrius, I can't answer your question.
Do the data provide? Oh my.
Do you see it? Do the data provide convincing statistical evidence? Boom. Right there. You got to run a test. Right there, that means run a test. Okay? All right, so it says that the proportion of all high school students who would respond that they were having a good day is different than 0.41. So what do I think right now is that proportion of high school students that are going to say I'm having a good day? So P equals 0.41. And what's my alternative going to be?
P does not.
Nice. And how'd you know that, Marco? It said different. That word different. Okay? We can all do this. All right, so we're running a one proportion z-test. All right, we're going to do it in the calculator right now. Ready? Make sure you have your calculator out. You turn it on. Make sure you're following along. I am recording, but you should practice right now and then do it later again. What? I already did. Thank you for making sure. All right, so let's go to stat. You see where it says stat? I know it's not on the screen yet. It will be in a moment. Stat. All right, so click stat. Come on, computer. Gosh, I hate the Wi-Fi in this school. Hits, yes, connected Wi-Fi. Good Lord, that took forever. Hit stat. You guys see where my cursor is on the word stat? So click stat. All right, and it will give you edit, calc, or test. Edit, calc, or test. What are we running? A test, so go over to test. Which one are we running? And be careful here. One proportion z-test. What number is that? 5. Just to let you know, you will never use number 1. You will never use number 1. If you go to test and hit number 1, you get it wrong. Okay, you're never using number 1. I don't want to get into it. It's from 20 years ago. Don't need it anymore. So number 5. Number 5. Just make me angry. Number 5. So click number 5. Demetrius?
You're a little bit late.
All right, now I've already put in all the stuff. Since you know me, I like to prep and make sure I know what I'm doing. All right, notice you should type it in since you don't have that. The null hypothesis says P equals 0.41. Do you see the X? What does the lowercase x mean?
That is the degree.
No. The number of successes. 245 of these high school students said that they had a good day. How many people did we ask? 600. That's our N. That's our sample size. 600. Notice, what does it say when my alternative hypothesis, I wrote down alternative hypothesis was not equal to. So you see how that one's highlighted? All right, and then you're going to hit down, down, down after you type those in. Go to calculate, then hit enter on calculate. Yes? Yeah, absolutely. Get your yogurt out, right? Chobani all day. All right, so hit enter. Oh, you got to have your breakfast, right? Even if you're 3 hours prior to school. Demetrius. All right. Our z-score was negative 0.083. Our p-value is 0.934. And then don't do this. I'm going to do it for you in the calculator, but I just want to show you something real quick. I think you can get the answer without doing this, but something cool your calculator can do. Let me rephrase. These calculators suck, but it looks cool. Oh man, so many reasons. You guys see where it says draw?
Yeah.
So if you click draw and hit enter, it'll give you this curve. And good Lord, that's almost all of the curve, right? Which makes sense. 0.934 is almost 100%. So let's think about this. And I know if Adrian P was here, he'd get this wrong. But let's think of a typical alpha. What's a typical alpha that we like to use? 0.05. And look at your p-value compared to that alpha. It's way above. It's not even close. That p-value is so much higher than any alpha you would ever use as a person. All right? So do we have enough evidence to reject the null? No, there's no way. All right? So definitely not any of these answers that say yes. It's got to be no, and it's because the p-value is greater than any reasonable significance level. Now, again, if you got that right without using technology, then you guessed well. Good job. Now you just saw why that is correct. That's not a knock on you, Wendy. I didn't teach you how to do it until this moment. Seriously, that's a knock on me. Don't worry. Questions on 15. Everybody good? I used to love these questions as a student because I knew my technology and I knew I didn't have to actually run the test or do hypotheses or do any like assumptions and conditions, but I knew how to get the stuff. All right. So I love these as a student. Maybe you will too. All right. 16. Okay. So the moment I read this one, all right, we've got 4 types of exercise: strength training, flexibility training, aerobics, and jogging. Oh, jogging. And then they're looking at the oxygen consumption levels. All right. Do you see how they have 40 members and the director randomly assigned, didn't mean to cross through it, 10 members to each exercise? The moment you read that, what should your brain be thinking? Randomly assigning them to a type. What is this? Those are called treatments. Those are called treatments, which means this is an experiment. All right, your brain needs to know that if you're randomly assigning people to treatments, this is an experiment. Okay, so I went through the first answer choice. Replication. Do you guys remember what replication is? Doing it again, but changing something. Is it replication to just talk about your 4 treatments? No. Replication would be doing this again with 40 different people. Maybe they're a different age group. Maybe you're going to do it in a different location. Maybe we're in Texas. Maybe we're talking about going to the United Kingdom. All right, so different place. That's replication. Because it's a 6-week period, no, again, you've got to do a completely different experiment. What are they writing down? What are they writing down? What are they writing down? Excellent. They're writing down the change in maximal oxygen consumption. Are they doing the type of exercise, though? This is trying to confuse you because they are writing down in terms of how much oxygen they consume, but it should not have to do with the type of exercise. It's not. And do you guys remember what experimental units mean? What are the experimental units in this experiment? Who is it? The people, not the exercises. So the treatments are the ones that we're assigning them to. And that's why I highlighted or underlined. Randomly assign them to each exercise type. Randomly assign each exercise type. So that should be the giveaway, that those are the treatments. All right, let's go to 17. All right, this one is the hardest one we'll do. All right, remember to write small. We have Sean and Evan are college roommates. All right, they have part-time jobs as servers in restaurants. It tells us that the distribution for each of their weekly incomes is normal with a mean and standard deviation. They give us the 2 different ones, okay? So I'll write those down real quick if you want. Here's Sean. His model, let's do this. I'll just do it as S. His is 225 with a standard deviation of 25. And then Evan is 240 with a standard deviation of 15. Okay? Assuming their incomes are independent of each other. That's a key phrase there. Which of the following is closest to the probability that Sean will make more money in a week than Evan? All right? So do you guys remember when it tells us that their weekly incomes are independent, I can actually take my S and subtract my E. All right? So that for the new model, this is the new model, where I'm doing S minus E, my new mean is going to be 225 minus 240. All right, what's 225 minus 240? That is negative 15. All right, and now here is my new sigma, and this is where, if you don't remember this, it's because I am not a good teacher, because I used to yell this at you. I want to find the standard deviation, all right, for the difference of two independent variables. Should be screaming something at me right now.
Oh, no. I remember when there was some difference.
Even though it's the difference, we should be doing add what? Variances add. Is that what you're going to say, Jesus? All right. Variances add. So this is a question. If you don't remember variances add, then you're not getting this right. Okay? So variances add. So here's how I find it. You ready? Remember, the variance is going to be just the standard deviation squared. So I do the square roots of 25 squared plus 15 squared. I'm going to make sure you know this, right? The variance, can you guys ignore the square root for a moment? Is everybody ignoring the radical? So you take the standard deviation of the first one, squared. Add the standard deviation of the second one, squared. That's the variance. I don't want the variance, right? I want the standard deviation, so you take the square root of that whole thing. Okay? That's variances add. Try to drill that into you in the first semester. All right, so let's go to our TI-84. Let's type this in. So the square root of 25 squared plus 15 squared. So let me get back here. So we have the square root of 25 squared plus 15 squared. All right, so what is our standard deviation for the difference in these two incomes? $29.15. It is money, yes. Did I say 15? Was that right?
Yes.
Yes, thank you. Yes, these are both dollars. Okay, so now here's where I think it gets difficult. We're trying to figure out the likelihood that Sean will have a greater income than Evan. Okay, so what I did here was I wrote down, right, my z-score, right, and I chose 0. All right, I'm going to find the likelihood that it's above 0 because I do Sean minus Evan. I need to have what number? What kind of number if Sean's going to make more money? If Sean's going to make more money, I'm doing Sean minus Evan. What is it? Positive. So I went with 0 minus, what is my new mean for my new model? What's my new mean for my new model? Negative 15. Nice. Over, and what's my standard deviation? Nice. All right, so this will give me the z-score, and I can use technology to find how much of the area is above this, right? Because I want to the right, because I'm going above 0. It has to be above 0. All right, so let's go in our calculator and do 15 divided by 29.15. Notice when you do 0 minus a negative, that should become a positive 15. Marco, you still with us?
Yeah.
Okay. So 15 divided by, and if you want to, sorry about that. If you want to really be one of those cool kids, I hit divided by second answer, right? Because if I put second answer, that's going to type in the previous answer of 29.15, but it's not rounded. I don't care. If you guys did 29.15, that's fine. Or second answer, you should get something close enough. And with stats, it's nice. You're just going to pick the answer that's closest anyway. All right, so I got 0.5145. 0.5145 for my z-score. All right, here we go. I'll show you what I'm going to do. So here's my curve. 0.5145 is just a little bit to the right. And I told you guys that I want to shade to the right because I want Sean's to be more than Evan's, which means it needs to be greater than 0. So to the right. So now I go to my calculator again and use the technology to tell me what that shaded area is. Do you guys remember how to get there from yesterday when we did this area under the curve? Let me show you. You go to second vars, because we're talking about a normal distribution. So second vars, because I want distribution. Okay? Do you remember which one where we know the z-score and we're trying to find the area under the curve? No, we know the z-score. We're trying to find the other. That would be the other way, Jesus, if we wanted to go backwards. Number 2, nice. Normal CDF, number 2. Okay, what's our lower number? 0.5415. What's our upper number because we're shading to the right? A bunch of 9s. Yes, we're going to go with that. Infinity. Fatima, you still with us? No? Right, it's helpful if you try to do it yourself. Okay. And then go down and hit enter on paste. Do I need to wait? Wendy, you good? And then just a couple of 9s. Infinity, essentially. All right, and so what is our probability that Sean makes more than Evan? Excellent. So about 29.5%. So 0.294, that's my answer. That's what I'm looking for in my answer choices. So 0.294. When I look at my answer choices, which one is closest to 0.294? Excellent. That's the one you're going to choose on the AP exam, whichever one's closest. The only time that rule doesn't apply, if it's asking you to find a new sample size for a particular margin of error in a confidence interval, you're going to always round up. All right, that one's very challenging. Number 18. All right, number 18. It says 36% of eligible voters voted in the 2014 elections. Wow, that is really sad. For a random sample of size 40, which of the following best describes the sampling distribution model of P hat? Oh my guys, we just did this problem, but we did it for a sampling distribution model for a mean. Now we're doing a sampling distribution model for P hat. Guys, this is the same chapter, chapter 18, but you need to remember how to find that new model. Okay, here's how we found it. It's the same P hat, or I guess I should say the same P. All right, so what's going to be my P? What's the proportion of voters that are eligible voters that voted in 2014?
36.
Excellent. So I know this is 0.36, so it can't be B and it can't be E. All right, and now let's do our standard deviation. And you guys just told me this formula. All right, standard deviation of P hat. It was the square root of P times Q over N. All right, so that's going to be 0.36 times 0.64 over, and what are the sample sizes? 40. All right, so if we go into our calculator, we will find that standard deviation. All right, so second, square root. I put parentheses to do the top ones first. Divided by 40. So I've got a standard deviation of 0.076. 0.076. Okay. Now, when you look at your answer choices, that eliminates D. All right. So the question is, do we think the sampling distribution model is going to be skewed, or do we think it's going to be approximately normal? Now, there's a legitimate way to answer this question for you using the sample size. What was that condition called? The success failure condition. Do you guys remember that condition where you have to do N times P, N times Q? Do you remember what numbers you're looking for there?
About
10 or more. All right, if you do that, you're expecting it to be approximately normal. So you can probably guess what 40 times 0.36 and 40 times 0.64 is. They're both 10 or more. But I'm just going to tell you this, guys, straight up, that I would be very surprised if the AP exam, all right, was testing you on this and would never have one that is always approximately normal. It's very difficult to get a sample distribution model of a mean or a proportion that's not going to be normal based on the central limit theorem. So just kind of going forward, you can assume that the sampling distribution model is going to be normal. All right, but if you really wanted to prove it, you would do N times P and N times Q. All right, 2 more to go, guys, and we're done. 2 more to go. We can do it. We can do it. 9 minutes. 9 minutes. We can do it. All right, 19. We've got a researcher at a college talking about consumption of beetroot juice. That sounds really good. and they want a random sample of 50 student athletes from all student athletes out of college. So keep that in your mind right now. We're taking 15 student athletes, so randomly getting 50, from all of the student athletes out of college. All right, so depending on the college you go to, you might have a lot of student athletes, not as many, all right, but you want 50. They were split up into two groups. In one group, they were given the beetroot and juice, and the other one, they're given a placebo. At the end of 6 weeks, the researcher compared the performances of two groups. Guys, this is called what? When we are randomly assigning people to a treatment. This is an experiment, all right? And we want to know, what is the largest population to which we can generalize the results of this experiment? The way I always answer this question, guys, is I always ask myself, what is the population that they sampled from? What is the population that they sampled from? What about the college? The student athletes at the college. So the only population they can generalize these results to are the student athletes at the college. Correct. I think this is a question that students make more challenging than it needs to be. Ask yourself, what's the population they sampled from? Boom, that's the answer. Let's go to 20. Last one. Do you guys know what this is called, this display here? Well, when it shows up. Ready? Ready?
I'm ready.
That. Do you know what that's called?
No, but I know what it is.
Okay. What's that called? It's a segmented bar chart, right? Segmented because you've got different segments. One segment is for return the survey. The other ones did not return. This question was about giving out surveys in different ways. In-class survey, given as a psychology experiment, they're asked to return it in the hallway of the psych building. And then in the dining hall, students watching the dining hall, they were asked to return a completed survey to a box outside the dining hall. Okay? Everybody good on that?
Yes.
All right, let's look at our statements about this. There is a positive association between delivery method and a rate of return. What do we think? I have no idea what that means. There's a positive association between delivery method and rate of return. That would be like if you're talking about one goes up, the other goes up. These are categorical variables. I don't know what that means. So then I also don't know what B means. There's a negative association between delivery method and rate of return. Again, that's assuming these are quantitative. They're not. Okay? Let's go to C. The number of surveys given using the dining hall delivery method was less than the number given using either of the other methods. That's trying to get you confused. Do I know how many surveys were given out? No, these are all percentages. So dining hall could have had the most, could have had the least, could have had the middle. I don't know. So anytime you're getting questions about a segmented bar chart with percentages, and they're asking you about number of, it ain't going to be that one, guys. All right, there's no way it can be that. I have no idea. It doesn't say anything about how many were given out. The psych delivery method displays the most symmetric results. The other delivery methods display skewed results. I think this is trying to get you guys to think because the bar kind of hits them around 50%, that you think that's going to be symmetrical. I mean, I have no idea what this is going to look like. No, it's not going to be that. All right. E is the only one that makes sense to me. The in-class delivery method had the greatest rate of return, right? It had the largest, I guess you would call that light gray block. And the dining hall had the least rate of return, which had the smallest light gray. That's the only one that actually is talking about the display that's given to us. So really try to focus on what is the display given and make your results about that, not about something else. All right, that's it for these next 10. Tune in next time for part 3.